For this one, I don't have it written, but we're going to assume that the x's are in the restriction from 0 to 2 pi, meaning just one revolution around the circle. We put a parenthesis on the 2 pi because 0 and 2 pi are coterminal. So I'm going to recopy this real quick. And notice this is an equation that's considered quadratic in form. Even though it does not look like a quadratic, it could be rewritten as such. So let's suppose we let t equal the sine of x. Well, instead of all those sine of x's now, we could say 2t squared plus t, and I'm going to bring the 1 over, minus 1 equals 0. Well, 2t squared plus t minus 1 factors. How does it factor? Good. 2t minus 1, t plus 1. So solving for t, we would get t equal to a half, and t is negative 1. But here's the thing, we did not start with t, we started with sine of x. So that would mean that the sine of x is a half. So notice we're back substituting, and the sine of x is negative 1. So then the question becomes, for what values of x is the sine of x 1/2? And now when we get this answer, our answer is only between 0 and 2 pi. So for what values of x between 0 and 2 pi is the sine of x 1/2? You would say x is 30 degrees, or pi over 6. And you could also say that x is 150 degrees. And now we do not have to do that k thing for 2 reasons. One, we have a single angle here, it's just sine of x. If it was a sine of 2x or a sine of x over 2, we would need to consider the x. We would need to consider the k to get our final answer. Look at our last example that we did. And the second reason is we're only in one rotation around the circle, so the k would say give us all the answers if we kept rotating forwards and backwards. But in one rotation, your final answer will not have the k. Lastly, sine of x is negative 1 when x is 270 degrees. And to be honest, we really should give our answer in terms of radians because they said x is between 0 and 2 pi. So the real answer really will be pi over 6, 5 pi over 6, and 3 pi over 2. So we had to do some factorization on this one to get our final answer. In our last one here, we'll also have to do some factorization. And even though I don't have it written, we are going to assume that x is between 0 and 2 pi. So just like before, we'll have to give our final answer in terms of radians. Well, what format does sine squared of x minus cosine squared of x have? Good. It has a difference of squares. So this would be the sine of x plus the cosine of x times the sine of x minus the cosine of x equals 0. Well, the first one would say that sine of x plus cosine of x equals 0. So bringing that cosine of x to the other side, it would say the sine of x equals the negative cosine of x. And then the second one would say sine of x minus the cosine of x equals 0, which means bringing the cosine to the other side. Sine of x equals cosine of x. So this one's a little weird because we have two functions going on, sine and a cosine, and we really can't easily write one in terms of the other. But we don't need to. Let's just talk about what they're saying. The first one says that the sine and cosine have opposite values. So if the sign were ignored, they would be equal, but one would be negative and one would be positive. That's what the sine of x equals negative cosine of x means. So where on the unit circle between 0 and 2 pi does that occur? Well, that occurs at 3 pi over 4. And 7 pi over 4. So notice in these locations, one of them is the positive radical 2 over 2, and the other is the negative radical 2 over 2. And the second one, sine of x equals cosine of x, where does that occur? Where are they the exact same value? Pi over 4 and 5 pi over 4. So notice in this scenario, either they're both radical 2 over 2 or both negative radical 2 over 2. So that would be our answer if it said between 0 and 2 pi in terms of radians. But as an added bonus, what if they did not have that restriction? So no domain restriction. If that were the case, notice that pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 are all differ by pi over 2, 90 degrees. So we would be able to just list the first one, pi over 4, and then add on multiples of pi over 2. Because if we go if we start at pi over 4 and keep going forward pi over 2 units or backwards pi over 2 units, we'll get all of the coterminal angles. But remember, please finish it off with k as an integer.